One of the places that we find situations that are modeled by quadratic functions is in geometry. And there are two major places that we're going to find quadratic functions in geometry. The first one is in computing areas. Remember, when we compute areas, we will always be multiplying two lengths together. If both lengths depend on x, we'll get a quadratic model. Let's see an example of a quadratic model we get from geometry. Suppose we have a rectangle, and we know its perimeter is 20 feet, and its area is 21 square feet. What are its dimensions? How should we understand this problem? This is a problem about geometry. A picture will surely help. I'm going to call the length of one of the sides x. Clearly the opposite side is also x. Just for now, I'm going to call the length of this other pair of sides w for width. I'm going to figure out what that is in terms of x in just a second, but having a name for it will help me with that. Right? Because what's the perimeter? It's the distance all the way around. If I walk all the way around this rectangle, I'll walk along two sides of length x and two sides of length w, and I'll have walked 20 feet altogether. To figure out what w is in terms of x, I'm just going to solve this formula for w, subtracting 2x from both sides. So the lengths of the other two sides are 10 minus x. What's the area of the rectangle? Well, it's going to be the product of the two dimensions. The area is x times 10 minus x. And I want to find what value of x will make that equal to 21. How should I solve this? Well, I'll multiply it out. I'll subtract 21 from both sides. And now, as I'm rewriting this, I'm going to write the x squared term first. And now I'm going to look at this for 10 seconds and see if I can see a way to factor it. And I can't, because I don't like negative leading coefficients. I could mess around if I wanted to, but I'm not gonna. I'm just going to pull out the quadratic formula. X equals negative 10 plus or minus the square root of 10 squared minus 4 times negative 1 times negative 21 all over 2 times negative 1. All right, working out this arithmetic inside the square root, I'll have 10 minus 84 is 16. 16 is a perfect square. This will be 10 negative plus or minus 4 all over 2 negative. So this will be negative 6 over 2 over negative 2, or negative 14 over negative 2. X equals 3 or 7. Oh, there's two answers. How should I understand that? Well, the first possibility is x is 3, in which case 10 minus 3 is 7. The second possibility is x is 7, in which case 10 minus 7 is 3. So in this case, 3 and 7 are the two dimensions of the rectangle. So my answer, 3 by 7 or 7 by 3. Another place that we might come across quadratic models in geometry is with the Pythagorean Theorem. Remember, the Pythagorean Theorem tells us that if we have a right triangle, so a triangle with one of the corners a square corner, and we call it sides A, B, and C, where C is the longest side, called the hypotenuse. and A and B are the shorter sides called legs, then A squared plus B squared equals C squared. How might this give us a quadratic model? Well, suppose that in a certain right triangle, the hypotenuse is 2 units longer than the longer leg, and the shorter leg is 7 units shorter than the longer leg. I'd like to find how long is each side. So I notice that everything is described related to the longer leg. I'm going to call my longer leg x. The hypotenuse is 2 units longer than the longer leg. So if this length is x, this length is x plus 2. The short leg is 7 units shorter than the longer leg. So this leg is x minus 7. Plugging all of these into the Pythagorean theorem, first leg squared plus second leg squared equals hypotenuse squared. Let's see, multiplying each of these out. X squared minus 7x minus 7x plus 49 plus x squared equals x squared plus 2x plus 2x plus 4. Collecting all the like terms on either side, 2x squared minus 14x plus 49 equals x squared plus 4x plus 4. Now, I need to get this in standard form, which means I need to get 0 on one side. Minus x squared on both sides, minus 4x on both sides, minus 4 on both sides. We'll get x squared minus 18x plus 45 equals 0. You know what? I think I may see what this is going to factor as at first glance. If you don't see what this is going to factor as at first glance, please feel free to solve this using the quadratic formula. But I see the two numbers whose product is 45 and whose sum is negative 18 are negative 15 and negative 3. So I'll have x minus 15 and x minus 3 as factors. So x equals 15 or x equals 3 are my solutions. 15 makes this factor 0. 3 makes this factor 0. Let's make sure that those both make sense as answers in this question. There's no reason there shouldn't be two answers. So 15 minus 7 is 8. 15 plus 2 is 17. That makes sense. 3 plus 2 is 5. 3 minus 7 is negative 4. Can a side be negative 4 long? Nah, that doesn't make any sense at all. That one's out, which means the solution x equals 3 is out because it doesn't make any sense in the problem.